row. So they spread the effect up and along the coastline. So you again get that sequential decay through the system. So the typical, what I haven't drawn in there is what the typical response is that of a big government like Australia is, I'll fix it with technology. We'll actually put in a sewage treatment plant so that it won't have as many effect with the tourists. It doesn't really work actually. You kind of marginally correct the effect, but the only real effect is to reduce that pressure, which to an Australian which thinks everybody should have the right to go to the beach is quite a horrifying idea. You cap the number of people that are allowed to go to a beach. So it's about thinking up smart ways of building. You just don't build as many beds, you don't allow as many campsites. So it's about thinking about incentives so people don't feel like they're being cheated, but there's still a value to the resort. The next big sector that gets a lot of attention is the oil and gas sector. So if you think about how many oil and gas rigs are involved, this is just an example. That black area in there isn't the oil spill, it's just actually the number of dots of oil rigs in the Gulf of Mexico. There's 7,000 oil platforms, of which 400 are active at any one point in time. So they really are, they're almost like a navigational hazard these days. They are a beautiful artificial habitat for animals that want to grow up the sides. And what the oil industry does is it models its production cycle, so it can see if it's going to be competitive, where the wage problems are, how many workers there are. Interestingly enough, it was only in the last 5 years that this oil reserve that they have at the bottom that they're sucking out of, they decided to make it limited. In the past, that was an unlimited resource that they were modeling. It sounds a little bit odd to an ecologist, but it was working fine because the pool was so big to what they could suck out, it wasn't a problem. But now they've got to the point where as much as they can get out is kind of what's there, then they have to worry about those interactions. Okay, next one is the transport sector. So these are all the air networks, shipping routes, roads, and big cities in the world. So you've got pretty blanket coverage there. So there's a few different things that they have to model in that instance. It's actually just the load, so how often do they have to replace stuff? It costs quite a lot of money to replace a road, for instance, so they have to think about that cycle of replacement. There's also what's actually flowing in and out, so they can keep track of economics for reporting and making sure everything's profitable. But there's also the problem of collisions and how you manage that. So there's quite a lot of traffic going in and out. So if you're sitting off the northwest of Australia, there'll be 20 boats lined up ready to come in offshore because they don't have enough entry points. But the port has purposely not put more entry points because there'd just be more boats. It's one of those things where they're actually controlling the amount of boats coming in by saying, you can't come, it's just too limited. Whereas they know if they doubled it, they just double the number of boats that were sitting offshore waiting to come in. You can also look at alternative management strategies that way. So if there's a risk of a collision, so what was the problem up on the northwest shelf was there was only one single way of getting in and out of the reef. Because Australia's two biggest ports both sit on coral reefs. So 25% of Australia's exports go out of a port on the Great Barrier Reef, and another 25% goes out of a port on the reefs on the western coast of Australia. So a lot of times they have very limited channels to come in and out of, which massively increases the risk of a collision and a catastrophic oil spill as a result, because these big boats are carrying oil. Okay? So one of the options was, what happens if they just literally dug another channel? So that's going to make the environmental groups really cranky locally. You've just literally blown up a reef to make another channel to let the boats go in and out. So that sounds bad. The dredging and the plume that makes around the port, that sounds bad. But it massively reduces your risk of a catastrophic oil spill. So that's good. So how do you actually trade off those tensions? The short-term environmental local cost versus that enormous cost that could stretch for 150 kilometres down the coast of Western Australia. The other part is the changed access. So one of the reasons that the coral reef in Western Australia doesn't get as many visitors as on the east coast of Australia, so there's 200,000 people that go to Ningaloo Reef and 1.2 million people that go to the Great Barrier Reef every year. So the Great Barrier Reef is like a very impressive place that you get to hear about this afternoon because we're going to play a game with it. But one of the biggest reasons that they don't go to Ningaloo is it's just hard to get there. So recently it's actually been interesting to watch because the biggest commercial airline in Australia used to be a regulated industry. They weren't allowed to go to Ningaloo. It was just one small company that was allowed in. They deregulated the industry get $99 fares to Dinglewood. It used to be $900. So it's massively changed the kinds of people and how many people are flowing into that system. Okay, so thinking on to other sectors that we might not be as familiar with, it's harder to dig up models for. So this is a map of North America. I don't know whether you can see it or not, but there's a little smudge there. So if you think about the Great Wall of China, which is supposed to be the only man-made object you can see from space, you actually have to use infrared, and you can see this little jagged line. That little white smudge is actually an open-cut tar sand line. So it is now the biggest thing you can actually see from space with your naked eye that's man-made. And it's growing, it's doubling in every 2 years at the present moment. It's just not worth Canada's dollar terms to stop it. Environmentally, it has other issues with it. And so that's why they do strategic assessments around that kind of stuff. What's the land use implications? What's the biodiversity implications? What's the health implications? So that they can trade it off. Places like Australia, that's also been an issue where the plumes from the mines, and particularly the salt mines, so when you mine salt, you end up with a lot of hot, salty, really salty water because it's mineral salts, heavy metals. That just gets flushed out. So the blue area in that underlies the grey one. Without any control, that grey stretch, which is about 300 kilometres long, was the area where that plume would have broken World Health Standards. So that's why they had to start regulating. That's why they use models. So they use biophysical models, but they also put in the regulatory models, including having to put in whether the guy is going to get caught. Who's going to go up there and test it? No one lives up there. Is it worth his while to go out to the plant every day and do the measurements? So that you actually have to think about the human incentives to pay attention to the rules. So I can tell you that the only guy who really goes out there every day before this regulation happened was the weatherman. Because I looked at the weather record and you can tell where he went on his 1 week holiday every year for the last 25 years because there was no weather recorded. But everybody else's, you might get one record a week if you're lucky. So they had to bring in the regulation, but think about what were the incentives to make the people actually do it. Okay, so one of the biggest ones that we know of from the climate models, where we're already starting to put people in, is land use. So this is a map of the world's land use in 1700. So pretty much all the green stuff is semi-natural. The blue stuff in the top north of India, it was actually villages. The grey stuff is sort of in really remote and uninhabited stuff. And the orange that you can see in Europe and parts of the Middle East was actually where there had been intensive agriculture. So this is the case today. So we have radically changed the land cover of the world, and that has implications for what happens in the climate models. And that's why it's actually included in the latest generation of climate models, because there is such an interaction and feedback. And it's a really good case of having to model at different scales. So they don't just have the gridded habitat, they actually delve down into the processes that are happening inside the habitat. So if we think about here, they can actually follow individual trees in some models. So they think about the cohort of trees and then a patch of trees up to the grid cell. It's also a really good example of the kind of simplifications you can make. So on the left here we have a tree, and on the right we have grass. So it's just thinking about how you can use simple shortcut to represent, those kind of industries. Then you can use a similar kind of shortcut to represent the human interactions in the system. So very simple rules can capture the gross behaviour that you're after. Sometimes just the general patterns is all you want. We see this a lot in urban planning now, where they're starting to layer up GIS layers to think about how they plan broad-scale land use, now that it's become quite a contentious issue and land is so valuable. So in places like Alberta, but lots of places around the world, they now play out scenarios of what future land use would be like so that they can check for the risks of biodiversity loss, catastrophic, the risk of infrastructure failure having catastrophic effects with flooding or extreme events, for instance, where they might want to put protected areas. Basically just trying to plan how things go. And they do that in the urban city as well, which I'll get to in a minute. But one area that they put a lot of effort into, so this is now a picture of Europe obviously. I don't know if you can see that there's a white tip there in Spain. That white tip is because it's actually a huge mass of greenhouses. So it's affected the local albedo and is affecting the local climate as a result of having that changed colour at the local level. So again, this is an area where a lot of effort has actually gone into modelling stuff at the farm. So they have soil, water covered, they have the pasture, they have how the managers, how the farmers actually manage stock rotations. They have models for their stock themselves, their wool production, or their beef production, or whatever else they produce. The farm managers, how he goes through his costs, the effects of weather on all that. But some of the biggest innovations have literally been about innovation, how the farmers actually work in social networks to share information. So that includes their political ideology, for instance. So if Ingrid and I are friends, or think we're friends, and if we think the same way about politics, so if we're both thinking of Australian farmers in the northwest, if we have fairly right-wing, so to put it, thoughts about farming, we're not going to necessarily listen to some of the left-wing guys that are suggesting we switch a bit into tourism or we use slightly different technology. We don't want to listen to those scientists. They fly in, they tell us all this information, they fly away again. They don't have to live here in this desert. But if I see that Ingrid's making money because she's letting tourists camp on her beach, and now she's actually made enough money that she's been able to put up some nice little chalets for them to stay in, I'm going to trust that. I'm going to share this information. How'd you do that? How'd you get that set up? So that's the information sharing innovation. So lots of ways of changing for people's behaviour is about thinking where that nudge effect is most useful. So for me to hear that I really need to go on a diet and hear it from the TV or read in a book is fine, but if there's a picture of me on the fridge, every time I go through, it's like, yes, maybe I really don't need that ice cream after all. So you think about where your nudge effects are, where you're going to get the most effect. So it's marrying psychology with how people do their behaviour. And that's what they're really starting to do in rangelands management, about teaching, by getting people to participate with them, getting them to understand why they can shift their behaviour and benefit. Then there's sort of more classical stuff in the catchments, but they're building in a lot of these other components we've heard from the other industries in the catchment models now, because it can actually affect it. So you heard about the example from Raghu the other day where they had people that were way away from the bay that had to think about how they used the system because of the way that it flowed through the catchment. And similar tools to the ones that Raghu showed yesterday, that have managers and scientists and just everyday people play this game in Queensland where they get to manage a map of Queensland to see if they can make the rivers have better water quality. So they have a report card system basically. Can you do better than the government to get the report card up on those different rivers? And so what it's done is help the people understand that it's not a very short-term thing, that it's A, very hard to do, B, that it's very costly, and C, they've got to have patience. And at the start there was some nervousness that they'd say, okay, toss the whole report card. But in fact it's now become incremental increase in your benefit. That's actually been what the people have responded to. So they understood that that river over there might be okay in 2 years, but that river over there was actually going to take 20 or 30 years. They're a bit more willing to wait now because they can understand it by playing it themselves. Some of the best examples of that kind of stuff is actually happening in Vietnam, where there's some modellers have gone in there to help the Vietnamese government, in fact the Southeast Asian governments, think about when you do things to the Mekong, what's the flow-on effects, both for your local population, what's the effects for the local population moving to already heavily cluttered urban areas as a result, but also the upstream conflict. So if you're China and you cut off all the water down the Mekong, that has potentially destabilising effects politically around you. So it's about having that conversation, so at all different scales, from individual to regional to national, they can think about sharing that resource. So this is different kinds of learning. So for instance, we've got farmers on their paddy fields, they say, can we collaborate over sharing water so that we both, we don't steal from each other effectively. That then involves a discussion with the regional government about what is the water allocation, and so on up the chain so that they can get the different levels of negotiation understood and the flow-on effects. Because if the farms don't work, if they go tits up in Australian farmers because they're on the back of their head, then you get more people, more urban poor, basically. What these models include is also an agent-based way of making decisions that's dependent on the season you're in, what kind of income you've got, what kind of things you can do off the farm, and that then dictates what you do on the farm. So it's a lot of those if then else statements coming through that you actually discuss with people. You sit down, that's how you populate these knowledge. You